Okay, so your quiz is out of 22 points, and these are how to grade it. So I'm not too picky about being exact. I know it said to round to the nearest tenth. So for the first one, you have a rectangular prism that is 20.25, 10.5, and 12.5 inches. Now, it doesn't matter which one's the length, width, and height because a rectangular prism can be rotated, turned on its side, etc., and they'll all be the same. So it would look something like this. You don't have to draw it, but I'm just drawing it so you have an idea of what everything is. This would be 20.25. This would be 10.5, and up and down would be 12.5. Okay. To find volume of a rectangular prism, it's the area. So volume is equal to area of base times height. Okay, and in this case, area of base can be calculated with a rectangular prism, can be length times width, and then we multiply it by height. So that works out as well because the base of this is a rectangle, so that works. Length times width times height, it doesn't matter the order in which you multiply. So 10.5 times 12.5 times 20.25. 20.25, we get a total volume of 2,657.8125. Let's get this over a little bit. Okay, inches cubed. Now this time around, I'm not dinging you on having the incorrect units, but on your next quiz and your test that's coming up, I will ding you if you don't have the correct units. Okay, if you rounded to the nearest tenth like I asked, you could have that. Okay, that works as well. If you got the correct answer, circle it. If you got the work done, at least these written out somewhere, you don't have to do it longhand. You get that point there as well. Okay. So the second one says how much wrapping paper, and wrapping paper specifically talks about surface area. Okay, anything with area, whether it be surface area, lateral surface area, any area, should always be units squared. Okay, so we got the same set. If you look in your notes on page, let's take a look. I believe it's on page 16. So we'll get the formula there for a rectangular prism. Okay, page, let's double check. Should be page 16. It's right here. Okay, so there's a surface area formula. Okay, there it is. So I'm going to use that, length times width, length times height, and width times height. So surface area, okay, surface area is equal to, and this is rectangular prisms specifically, okay, I have multiplying 3 sets. Okay, I should have length times width. So well, I'm just gonna write the numbers down. Actually, length, length, and then I'll put width, 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 and then height, height. No two sets are exactly the same. Okay, every set is a different pair of numbers. Okay, and so let's fill in some numbers. Our numbers are all the same as before. 20.25, 20.25, and then let's just change colors. 10.5, 10.5, and then lastly 12.5 and 12.5. And to multiply them all up, I end up with 500, and then multiply and then add, I end up with 597 inches squared. But then I have to multiply it, I forgot to write this down, multiply it by 2. The surface area, I'm going to double that, so surface area will be 1,194 inches squared. Again, this time around, if these are incorrect or unlabeled, that's okay. But on your next quiz or test, it needs to be there. Now, you didn't have to do it that way. if you did it and you added them all up, doubled them, and then added them up, cool. Doesn't matter the order in which they come in. Okay. Tyler enjoys the fish so much that after his birthday, his family decides to take him to a famous aquarium. The tank is similar. Keyword similar. Okay. If they're similar, that means same shape, different size. Okay. So that means at a scale factor of 8, each of the lengths, so each length increases by 8 times. Okay. Now, each is a key part. Length increases by 8 times, not the volume and not the surface area. Okay. You need to be sure that you're reading the question. It asks how many times greater is the volume. We're looking for times greater. That's what the question is asking. Okay. So in your notes, I'm using period 3 as an example. We're looking for the amount, how much larger it is. So if you go to 1.4, specifically page 22, okay, whenever we're talking about volume, we are specifically talking about volume factor, which is the original times scale factor cubed. Okay, so that means that in our quiz, if this is the original, okay, this is the original, okay, and then we have the new size, this is the new one, okay, original, this is new volume, okay, and this is our original volume, okay, then we need to multiply by scale factor cubed. Okay, this is what I'm looking for because that is what the question is asking. How many times greater is it? It is scale factor cubed times larger. So it doesn't ask for the new volume, but you can use that value here. Our old volume was 2,657.8125, and I multiply that by a scale factor, which is given to us, of 8 cubed, and that should equal a new volume of something super huge, which is 1,360,793.6 inches cubed. Now, you didn't have to figure out the new volume. This new volume, if you did not come up with this part over here, that's okay. It doesn't ask for that. If all you did was tell me that you came up with 8 cubed or 8 times 8 times 8, or if you told me 512 times larger, any one of those 3 answers in blue circles counts as full credit. Okay, because that's what the question is asking. Okay. Now, if you didn't come up with that and you came up with the new volume here, okay, if you came up with this new volume here, okay, then you get 1 point because you're missing out on the question, but you did all the work to get 1 point. You did the work, you just forgot one last little bit, which is dividing the new by the old. Okay. So, second question, how many times greater is the surface area? Again, times greater surface area. So, in your notes on page 22, it says here, area. There we go. It is scale factor squared bigger. Okay. So here, if you have your original, we'll do the same setup, same way. We have the original surface area times scale factor squared, and that should equal our new volume. Sorry, new surface area. Okay. So again, we didn't have to do this part, but I'm going to show you what it looks like. 1194 was your original, 1194 inches squared, and then we're going to multiply that by the scale factor of 8 squared. That should give us our new surface area, which is going to be 76,000 416 inches squared. Now, this is what I'm looking for one more time. We are looking for this. 8 squared, 8 times 8, or 64 times larger or greater. Okay, I'm looking for these three things. It is that much times larger. Okay, again, if you came up with just this part, if you came up with this, that's 1 point. Okay, right. So next page, question number 3 says a pool table supply company is making cardboard box package new cubes of pool cue chalk. Each cube of chalk is 1 cubic inch. The company considers the ways to arrange 16 cubes. Which one would require the most cardboard? They all carry 16 cubes. The one with the most will be 16 by 1 by 1. That's this one. Okay. And the one that requires the least would be this one. 4 by 2 by 2. Okay. And the reason why is this one is the closest to a cube, closest or most like a cube, closest to a cube. And this one is the least like a cube, least like a cube. Just that simple. Okay. You could say that if you did the work and you found the surface area for each, you could say I found the surface area for each one, and this one was the smallest and this one was the biggest. That's fine also. But again, we're trying to figure out ways to understand the math so we don't have to find the surface area of each one. We just know by looking at it, and we can explain why. More like a cube, less surface area. Less like a cube, more surface area. Go and add up your total possible points. Okay. Grand total points for the first page is going to be 12. Okay. Add the first page. Pause the video if you need to. Okay. Second page looks like this. Okay. Now this section here is my base. Okay. And a lot of people got confused because they didn't have this side length or this side length, but it tells you right here that this is an equilateral triangle. So things that we talked about in the first unit are very important. That means this side length here is going to be 4 also, and this side length here is going to be 4 also. Now, if you look on your notes on page 2.1, which is going to be page 25, right there, that tells you how to find the surface area. There's a surface area. And if you look on page 27, that'll give you the volume of a triangular base pyramid. So 25 and 27 will give you the two values. I'm going to use this one. I'm going to make a net for that. Okay, so here's my net. That's this triangle here, and there's a mirror image on the other side. That's this one over here. Okay, this one will be 4 times 3.46. That's my triangle divided by 2. This one should be the same, 3 times 3.46 divided by 2. Okay, and the distance from one triangle to the next triangle, from here to here, that's going to be 8.25, and this is also 8.25, and the distance across is 4 because this is 4. Okay, so that makes this one 4 times 8.25, which is 33. There's one more on this side, that's 33. There's one more on this side, that's also 33. So we can point to this as our work and say 33 times 3 plus the bases, which is this ends up being 6.92. Oops, that's not a 2, that's a 9. Plus 2 times 6.92, and that will give us a grand total of 112.84 inches squared. Again, if you got 112.8, if you got 112, if you're within 1 or 2, that's completely fine. But I should see the work. If there's a drawing, that counts as work as well. Okay, I'm not too picky about exacts. Again, right now, if this is incorrect, if you put cubed or if you forgot to put it, that's okay. Next quiz, it's not okay. Okay, part B says how many square inches of cardboard are needed to make the larger package. I'll set it the same way. Here is my triangular base. Okay, and away from it is another triangular base. So it looks like this. Set up the same way as the last one. Those two triangles are 16 by 13.86, and if we connect them, they are 33 inches apart. Okay, and then that means each one is 33 by 16 for this space right here, which gives me 33 by 16 is, oh, let's multiply it. 33 times 16 gives us 528. So 528. So each one of those green rectangles is going to be 528 times 3. And I've got the blue section, which is each base 16 times 13.86 divided by 2. And that each of these is going to be is going to be 110.88. Again, if you rounded and got 110.9, that's completely fine. So two of these, 110.88. You add them all up, and we end up with 1,805.76 inches squared. Okay. Again, you're within 1 or 2 because you rounded, no big deal. Okay, the next one says cubic inches. So since it says cubic inches, we're talking about volume here. Okay, there are a couple ways you can do this. Again, same setup as last time. Area of base times height, and we already got the area of the base. The area of the base is right here, the area of the triangle. So that one is going to be 6.92 times a height of 8.25, and we get a volume of 56.744. Some of those of you guys who rounded got 57 inches squared or 57.1 inches squared. That's fine. Sorry, I said 57. 56.744. Okay, so any of those are okay. If you're within 1, it's not a big deal. Okay, and the other one's set up the same way. Area of base. In this case, the area of the base of the big triangle is 110.88 times the height or the distance from one base to the next of 33, which equals a grand total of 3,659.04 inches cubed. Again, if you didn't get this or you rounded and went up to 0, no big deal. So there we go. All right. That means that it's $2 for every 56.744 inches cubed of chocolate. Now, we have a new chocolate that we're trying to figure out the price. This is what we're trying to figure out, but is 3,659.04 inches cubed of chocolate. This is how much chocolate? How much chocolate? Okay, there it is. Okay, and to go from one chocolate to the next, what do I multiply by in order to get from one number, from the 56.744 to that 365904? I have to multiply by 64. So that means I have to multiply by this one by 64 as well, and we get a new price of $128. I wasn't really concerned about the cents, but it should be 128. So we've got 128.04 if you rounded, but that's okay. $128. Now I know it sounds like a lot, but keep in mind this chocolate is 33 inches tall. That's about the size of a small child. That's a kid life-size chocolate bar. Okay. All right, total up here. Out of 10, whatever your points might be, add them up with the first page and put it in the top over here. It needs to go in the back bin. If it doesn't go into the bin in the back, then I can't give it a score. Okay, so make sure your score's on there. This is the end of the quarter, this week's end of the quarter, so these need to go in. We have another quiz next class. Okay. All right. Pause the video if you need to. Go ahead and get your notebook out. And we are going to work in, let's go with period 6 notebook. Okay. All right. Our notebooks are pretty much the same. This one is going to be 0326. I'll stop it there and we'll split the video up a little bit.